Okay, recall from our last video that we have two scenarios that we're dealing with. First, if your object is at rest or at constant velocity, therefore it's not accelerating, and therefore the F net is going to equal 0, which means our applied force and frictional force are equal to each other, and our force of weight is going to equal the normal force. So that's our scenario over here on the left. On the right, we have the second scenario where the object is not at rest and not at constant velocity, therefore it's accelerating. So our net force is going to equal the applied force plus the frictional force, which are opposing, so you'll subtract them. And the net force equals mass times acceleration. This scenario, the weight is still equal to the normal force. So let's look at our first example. And for each of these problems, because we're dealing with horizontal surfaces, we're going to go ahead and draw our cross where downwards is the force due to weight. Realize that's the same as the force due to gravity, which is equal to mass times gravity. The opposing force to that is the normal force. Then we have the applied force, which is opposed by the frictional force. So as we read our problem, it says what friction force, so we don't know the frictional force, must be overcome to start a 50 kilogram object. That's the mass, 50 kilograms. So the force due to weight is 50 kilograms times 9.8 meters per second squared. And if we multiply these two, then we'll have the weight, which is 490 newtons. And they tell you that you have a coefficient of friction equal to 0.35. So first, we're going to deal vertically. You always want to start with the vertical scenario. So we know the weight is 490 newtons, which means we also know the normal force is 490 newtons, because the normal force is equal to the force due to weight. Now we're going to deal horizontally. And we don't know the applied force, but we don't really need it because we're just trying to figure out the force of friction, and we're going to use the coefficient of friction to determine this. Our equation is the coefficient of friction equals the frictional force divided by the normal force. We do know the coefficient and we do know the normal force, so we can solve for our frictional force. I'm going to rearrange the equation. Frictional force is equal to the coefficient of friction times the normal force. And so that's going to equal 0.35 times 490 newtons. And so that's going to give me a frictional force of 171.5 newtons. Example 2. And again, we're dealing with a horizontal surface, and so I will draw my diagram. Force of friction, force applied, force normal, force due to weight. Okay, it tells you have a 400 Newton object. That's the weight of the object, 400 newtons. And it's being pulled over a horizontal surface. If the coefficient of friction is 0.23 and the applied force is 120 newtons, what is the acceleration? So because there is an acceleration present, this is scenario 2. So recall that the object is accelerating. So it's not at rest or constant velocity. So you have an F net that equals the applied plus or minus the frictional. And so we're going to end up using F net is equal to MA for this particular problem. Okay, so this is going to have several stages, and I'm going to do my best to color coordinate for you. So stage 1 will start in purple. So purple will be step number 1. And the first thing I need to do is vertically realize that vertically my weight is equal to 400 newtons, and that's going to be equal to my normal force, 400 newtons. And so that's my first step. My second step, which I'll do in blue, is going to be to realize that using the coefficient of friction equation, I have the coefficient of friction and I have the force normal. So I need to figure out my frictional force. So the frictional force is going to equal the coefficient of friction times the normal force, which is 0.23 times 400 newtons. That gives me a frictional force of 92 newtons. So this is 92 newtons. Okay, step 3, go ahead and put in red. Step 3 is I need to use my frictional force and my applied force to determine the net force. Remember that the net force is equal to the applied force minus the frictional force. So if I do this, I'll have 120 newtons minus 92 newtons, which is going to give me a net force equal to 28 newtons. So my net force is 28 newtons. See what other colors I have available for myself here. We'll go with green. Okay, so lastly, remember we're still trying to determine the acceleration, and the F net is equal to mass times acceleration. My F net is, well, so essentially, let me rearrange this first. I'm going to divide both sides by mass, and so acceleration is going to equal the F net divided by the mass. I have a problem. I have my net force. I'm looking for the acceleration, but I don't have the mass. I do, however, have the force due to weight. And so I can take that equation, and let's see what color we'll use for this one. Go with the nice orange color. I can use the force due to weight is equal to mass times gravity to determine my mass. I know that the weight is 400 newtons, and if I divide that by gravity, 9.8 meters per second squared, then that's going to give me my mass of 40.8 kilograms. And so now I can come back to this equation right here, and I'm going to solve for my acceleration. Acceleration is going to equal the net force, which if you recall is 28 newtons. So my net force is 28 newtons divided by 40.8 kilograms, which is going to give me 0.69 meters per second squared. That was a lot of steps just to come up with an acceleration. So I'll do a little bit of a recap very briefly. We started out knowing the force due to the weight, which is equal to my normal force. Then I took my coefficient of friction using blue, this equation. I solved for the force of friction. Multiplying coefficient times the normal force gives me the force due to friction. So that's this number right here. The third thing I did was in red. I determined the net force, where I subtracted the applied minus the frictional to get 28 newtons. The fourth thing that I did was I needed to find, that would be in green, using F net, I want to get the mass times acceleration to determine my acceleration. However, I had a little moment where I had to do another calculation here, because while I have the F net, I don't have the mass. And so to get the mass in orange, we took the weight, which was 400 newtons, and we divided it by gravity in order to get the mass, 40.8 kilograms, and then finally I completed this equation by dividing the net force by the mass to get the acceleration.